In section 6.1, we'll be talking about polygons, and this will start our unit that will be labeled Unit 6B. So our goal for section 6.1 is to identify, name, and describe polygons. A polygon is a closed-in figure. The sides are segments, so there are no curves or arcs. And it's the union of three or more coplanar segments such that these two items are true. First of all, each endpoint can only be shared by exactly two segments, and no two segments with a common endpoint are collinear. So there has to be less than a 180-degree angle. They can't be two segments that form a straight line. Some examples: the top figures are polygons. They are segments being connected. There are no arcs or curves, and each segment is connected to another one at one endpoint, and there are only two segments at those endpoints. The bottom two figures, down here, are not polygons. This figure kind of looks like an X in the middle, has four different segments coming to a point. The second one has a curve, so those are not polygons. When we name parts of a polygon, we're going to name three different pieces. We're going to name the sides. Our sides are segments, so we can list the segments. So we have segment AF, and you could call it FA. Segment FE, and again you can call it EF. Segment ED. Segment DC. Segment CB. And segment BA, and you could call it AB. If there are 6 sides, we should have 6 segments listed. Naming the angles, make sure you use your angle symbol. So we have angle A, angle B, angle C, angle D, angle E, and angle F. Naming the vertices. A vertex is a point where two segments meet. So all of those letters are also vertices, but if you're asked to name a vertex, it's a point. So be sure you use a capital printed letter. So point A, point B, point C, point D, point E, and point F. We have consecutive angles. We talked about consecutive interior angles in the first half of geometry, and those were the two in between the parallel lines or in between two lines that were right in a row. When we talk about consecutive, it means in order or in a row. So these are two angles that follow each other and share a common side. For example, if I chose angle B, a consecutive angle to angle B would be angle A. A different consecutive angle to B would be angle C, so two right in a row. We also have consecutive sides. These are two sides that have the same endpoint, so we could do segment AB, and I could either use a segment that has the endpoint A or the endpoint B. So we could do segment BC, or I could do segment AB and segment AF. They need to have a point in common, two consecutive sides right in a row. Diagonals are segments that join two non-consecutive vertices. So if you look from point A, there will be 3 diagonals. We can't go to F because that is consecutive. Non-consecutive, there's one that goes to E, one that goes to D, and one that goes to C. So there are 3 diagonals. There are 2 types of polygons we'll be discussing. Those are convex and concave. A convex polygon, if you pick any 2 points and connect those 2 points with a segment, the segment always stays inside the figure. So you can pick a point here and a point here, and that entire segment is inside the figure. A concave polygon, or a non-convex polygon, if you pick 2 points and connect it with a segment, there will be a segment that goes outside the figure. Concave means one side of the polygon caves in. We can name our polygons by the number of sides. If it has 3 sides, it's a triangle because the prefix tri means 3. A 4-sided figure is a quadrilateral. 5 is a pentagon. 6 is a hexagon. 7 is a heptagon. 8 is an octagon. 9 is a nonagon, 10 is a decagon, and 12 is a dodecagon. You will be responsible for knowing the names of all of these polygons, so be sure you write these down so you can go back and study them. We'll talk about some other classifications for polygons. We have equilateral. Equilateral means all the sides are the same. So we're going to use our quadrilaterals for our examples. An equilateral quadrilateral would be a rhombus. All four sides in a rhombus are the same. We'll also use equiangular. An equiangular polygon means all the angles are congruent. A rectangle is an equiangular polygon. All the angles are the same. They're all 90 degrees. When it's both equiangular and equilateral, it's called regular. These are ones that are perfect figures. All the sides are the same, all the angles are the same. So a square is a regular quadrilateral. It's a four-sided figure that's regular. It's both equilateral and equiangular. We are going to work with a few theorems in Chapter 6. Theorem 6.1 says the sum of the measures of the interior, the inside angles, of a quadrilateral, a four-sided figure, is 360 degrees. So I can give you any type of quadrilateral, give you 3 of the angles, and ask you to find the fourth one because they're all going to add up to 360 degrees. For example, we have quadrilateral ABCD. Angle A is 70. Angle B is 80, angle C is 40, and angle D is missing. So I'm going to call angle D X. If I add these up, 70 plus 80 plus 40 plus X, all 4 of them, should add up to 360 degrees. 70 plus 80 is 150, plus 40 is 190, plus X equals 360. To find the measure of the missing angle, we're going to subtract 190 degrees. And we'll get that X is 170 degrees, which is absolutely fine. Just remember we can't have any two segments that form a straight line that are next to each other. The second example, the same picture, quadrilateral ABCD. Angle A is 80 degrees, angle B is 70 degrees, angle C is X, and angle D is 2X. Again, we're going to total these up, add everything together as a sum, 80 plus 70 plus 2X plus X. And since it's a four-sided figure, based on Theorem 6.1, they should add up to 360. So using like terms, remember that if you have like terms, if they're on the same side of the equal sign, you just push them together. We don't have to do any opposites unless we're going to the other side of the equal sign. So 150 plus 3x equals 360. To get x by itself, we're going to subtract 150. So 3x equals 210 degrees divided by 3, and x is 70 degrees. Now, you might have a problem that says to solve for x. You might have one that says find the missing angles. If I was asked to find the missing angles, I would state that the measure of angle C is 70 degrees. Angle D is 2 times x, so 2 times 70 is 140. So the measure of angle D is 140 degrees. We'll be working on homework on page 325 to 328. We're going to do numbers 12 through 34, 37 through 39, 41 to 45, and 54 to 59.